And welcome everybody from my side to our presentation today. It's the second time in a row we are here. I was here also last year, and I want to present an update on the activities we have been doing in relation with SCION. I'm the head of the Cyber Defense Campus. We are part of the Swiss Federal Department of Defense, and our role is we are responsible for research and innovation in any topic that relates to cyber. And we do some technology research, innovation, and also evaluation. And one technology we have been focusing on quite intensively over the last years is about the security of wide area networks. Wide area networks are networks that connect distributed sites over larger regions. As you can see, for example, on these pictures, we have had presentations in this afternoon from large financial institutions that typically have sites distributed across the world. But we have also large wide area networks that are used to send and transmit government data that is quite sensitive in nature. We have also, for example, armed forces that use wide area networks also to transmit military and sensitive data around. Or, for example, the hyperscalers, typically Google, Microsoft, and so on, they also operate their own wide area network to transmit data, to synchronize and replicate data between the data centers. So this is why these wide area networks can be it's very important to also secure those accordingly. Now, there are two different approaches how you can do this. And the first approach, which I call the poor man's approach, is to build a wide area network using a VPN. You can see here two sides, on the left and on the right. You connect them by having a VPN device on one side, another VPN on the other side, and then you encrypt through the VPN tunnel your data, and you tunnel basically the data over the internet. This is the poor man's approach because it's very cheap, and it's also, but it's very easy to deploy. You can deploy that very easily in a quick amount of time. But the drawback, as you can imagine, is that this solution has drawbacks in terms of resilience. The internet is not necessarily very resilient. Also, you may have drawbacks in terms of performance, and in particular, you have drawbacks and limitations in terms of security and privacy, because the internet has not been designed for security and privacy. And you know there are different types of attacks, distributed denial of attacks that may happen in the internet, also BGP hijacking, and all sorts of other vulnerabilities in the internet. And this is why many organizations that care about security, they are often build their wide area network using dedicated infrastructure. You see here on these pictures leased lines or fiber optics that many organizations that can afford it deploy. And then they build their own wide area network based on this dedicated infrastructure that is completely independent from the internet. So this gives you, of course, much better security, but on the downside, it's very costly. It costs a lot of money, these dedicated connections, and also the cost associated with operating, the operational costs of maintaining and operating a wide area network. So as you can imagine, the ultimate goal would be that we can have secure wide area networks that have the same security properties as these dedicated networks at the cost of a VPN connection. That would be the ultimate goal, but it's difficult to achieve. But we have been thinking about this problem, and for example, the military is using and has built over the past dedicated infrastructure to have networks, wide area networks that are secure, resilient, scalable, and highly performant. But the idea here that we're investigating, if we can have similar security guarantees, similar properties as these dedicated military networks, but using shared infrastructure. And this is basically our vision. We are currently following at the moment: how to build a military-grade wide area network without relying on your own dedicated secure infrastructure, but by using a shared infrastructures. And obviously, as I mentioned before, it's not something that is very trivial to achieve over the internet. So what we are looking at are different approaches that would allow us to have the same security properties, but using this shared infrastructure. Using the infrastructure, for example, of classical internet service providers. And for this vision, we have been looking quite intensively at SCION, because SCION has some properties that would be really interesting in this context. So we have been looking at SCION in terms of research, innovation, and in terms of the evaluation of SCION for this vision. For example, in research, we have been, over the last years, collaborating a lot with ETH, with, for example, Adrian Peric, David Basin, and other groups on developing further SCION in order to fulfill our security requirements. We have been also working closely with, for example, with the armed forces, also at developing use cases that will rely on SCION and that would provide this secure connectivity over shared infrastructure. And also this year we have been extensively in evaluating the security of SCION, of the SCION network as it is deployed at the internet service providers. So our journey started in 2020 because back then we decided that we will build our own SCION lab based on commercial offerings. 2020 was also the moment, a milestone, I would say, of SCION, where we could have 3 independent offers from 3 internet service providers in Switzerland that would give us some connectivity at our 3 locations of the Cyber Defense Campus in Thun, Lausanne, and Zurich. So we created this SCION lab. We connected, that is basically connecting these 3 sites. And we had our inauguration of this infrastructure back in 2022. You can see on these pictures. On the right, you see, for example, Martin also was at the inauguration. You can see also Lothar Thiele and also Adrian Peric, who participated in this inauguration. And you see on the left side, this is the General Secretary of the Swiss Federal Department of Defense that is plugging in the first cable of our data center into the SCION network. This is our symbolic start of our SCION journey. Then last year in 2023, we additionally connected also another site, which is in Tallinn, in Estonia. We have there an employee working together with the NATO Center for Cyber Defense. We will see that later on this center is also organizing some cyber defense exercise, and for us it was interesting to also test SCION and the WAN capabilities to connect another site that is outside of Switzerland and that would go also over different ISPs across Europe. So that's what we did in 2023. And this year, we had for the first time an exercise. This is basically the exercise that this center in Tallinn is organizing every year. It's the largest cyber defense, live fire cyber defense exercise in the world, where many different teams participate, including Switzerland. There is a team represented by the armed forces, a blue team, that also participates every year. And we see here on this picture, for example, on the right, we have the Major General Simon Müller, who was performing this cyber defense exercise from Switzerland over a SCION connection to Tallinn. So basically what we did here, we have Switzerland, the blue team sits in Switzerland, but the infrastructure for the whole cyber defense exercise and the red team that is attacking the blue teams operates from Tallinn, and there were 3 connections, one over the internet, one over Starlink, and one over SCION, to demonstrate also the capability of this technology in the context of cyber defense. And now I want to give the word to Roland, who is a scientific project manager at the Cyber Defense Campus, and he will be presenting the work we have been doing on secure WAN interconnection based on SCION. Please, Roland.
Thank you very much. The project that I will be going to present, this was joint work together with colleagues from ETH, from Adrian Perrick's group, and it was published this spring in International Conference for Cyber Conflict in Estonia. The main question that we were asking ourselves, this is also what Vincent already mentioned before, how can we build secure wide area networks on shared infrastructure, so on the infrastructure of public internet service providers as opposed to dedicated leased lines? The first question here is, what do we actually mean by secure? Because that's not so clear sometimes. What we here refer to is the so-called CIA triad that probably most of you know. The C stands for confidentiality, so data should not be visible or accessible for people that are not authorized to access it. Integrity, meaning that the data should not be manipulated, and availability, that the data or systems should remain available. Ideally, when you design a system, you want to be here in the middle, and you want to have perfectly all of these 3 properties. Now, in practice, that's hard or impossible, but still, it's a good goal to design a system. If we look at the threats in each of these 3 categories in a bit more detail, we see for confidentiality mostly threats that are related to eavesdropping on payloads of messages or on metadata, and also traffic hijacking that can be a threat against confidentiality because the attacker can attract traffic that they would normally not receive. Then in the integrity category, we have traffic injection, so that's an attacker injecting some false messages, or traffic modification when an attacker modifies messages that are sent around. And then in the availability category, we have mostly threats related to denial of service. That's an attacker with access somewhere on the path that can maybe drop packets. It can again be traffic hijacking when the traffic is hijacked into a black hole. It can be congestion, which is similar to denial of service, but without the malicious intent, so just normally occurring high load in a network. We have then the volumetric denial of service attacks, which is kind of the congestion, but caused with a malicious intent. And we have topology changes that can have an impact on the availability. For example, some routers fail. So we want to have an architecture that performs well and addresses all these threats. And in the remaining of the presentation, I will first present to you what components we suggest should be in this architecture. And in the end, I will show you a bit the roadmap that we see where what should be followed now until we have a deployable version of that architecture. Looking at the components, we go back to the table that I've shown before, and we now extend it by one dimension here with the mitigations. Now, one of the first things that comes to mind when protecting networks would be encryption. That already solves part of the problems related to confidentiality. Usually, encryption protects payload quite well. Metadata, such as packet sizes or packet direction, timing information is not so well protected because most encryption solutions are quite efficient in a way that they protect the messages about as well as this packaging protects its content. While on the other side, what we would like to have is more that traffic looks somehow like this, so it's much harder to guess what is going on inside. And in order to address that, we add another mitigation that is called traffic shaping and padding. So that's now adding, changing the shape of traffic and adding padding such that the packets that are sent around in a network are no longer recognizable for what application they are belonging to. Then we have seen already the problem of traffic hijacking in past talks today. That's an attacker somewhere that can, in today's internet, with faked BGP messages, attract traffic that they would normally not, should not be able to attract. And this, we have seen a lot of examples on this in Chris' talk in the morning. We have seen that this can happen because of mistakes, but it can also happen with malicious intent. And in both cases, it's of course not a good thing to have. The mitigation technique here is path control, and you will be very surprised by what system one could use to address that. But more on that later. Another thing that the attacker could do is sending a lot of traffic to our infrastructure, so kind of a denial of service attack. And in order to address that, we have a whole set of mitigation techniques, because denial of service attacks, they come in many different shapes and forms, and it's depending on what kind of attack, there are different techniques that can help to mitigate them. So we have these, all these techniques here, the filtering of traffic if it's possible, authentication of the path or the traffic that at least allows to determine who was the sender and what was the path that the traffic took. Or if it's maybe not possible to differentiate between denial of service traffic and normal traffic, one could at least try to prioritize the traffic that looks like it's not denial of service slightly higher, so that if traffic gets dropped, then it's the one that mostly looks like it could be a denial of service attack. So now we have this entire matrix of threats and of mitigations. And the next question is how can we implement these mitigations? So that's the next part of the talk. For encryption first, there are many encryption solutions like VPN tunnels. We've put here IPsec, there is WireGuard, there are many other ways to create and to encrypt the tunnels, so that's not such a big challenge. Then for path control, we all know that there would be SCION that provides that. And SCION, in its basic version, I would say, contributes to path control, but then there are several extensions that are based on SCION that address many of the remaining challenges and mitigations that we need. We have here one thing called a lightning filter, then we have Fabrit and Helia. These are all papers or systems that were developed at ETH. And for Fabrit, I would like to go a bit more into the details. Fabrit is a system that lets you select paths not only based on which ASs the path should contain, but also according to more flexible attributes. So for example, one could say, I want my traffic to be sent only over routers of a certain vendor, or only over routers with the latest firmware version, or over routers that are powered by renewable energy, whatever the policies the networks offer. And that gives, of course, much more flexibility, and the motivation for that were cases such as this one, when it turns out that there are vulnerabilities in network devices. We have seen the example of the VPN provider before. That was a critical vulnerability in a firewall product, and such things, they happen from time to time all over again. And then this Fabrit system could allow you as a sender to specify that you want to send traffic only over the routers that have the latest patches installed, for example. So that was about the SCION part. Then there is another dimension, and that is that a lot of the attacks today, they happen at very high bandwidth. So we've all heard about these denial of service attacks that are now executed at many terabits per second. And addressing such attacks, or even being able to analyze traffic on these rates, requires some special hardware. And that's why we have the last two technologies here. These are technologies that use so-called programmable data planes. So that's a way to implement defense systems or other systems as well directly in the data plane of a hardware. And the main benefit of that is that you can run these systems then at several terabits per second without having an impact on the network performance. And there's one, the ACC Turbo system, which prioritizes traffic that looks like it is most likely not part of a denial of service attack. And then there is DITO, which is doing traffic shaping and padding in order to prevent the traffic analysis attacks. So now we have all these technologies. Together they address all the threats that we have identified before. So the next step is now, how can we get that running in our network? And that's what I will be talking about in the last section of this presentation. Going back to the table that we had before, we have IPsec and SCION connectivity. IPsec is very widely used. Setting this up is not really a big challenge. We have SCION connectivity, which is also quite widely available, maybe not in all ISPs, but in many places. But then the challenging part comes with all the other systems. These are systems that are mostly implemented as prototypes in academic research papers, but they are not yet production ready. So our main message or our main wish here would be that in some time in the future, we would have an extended version of SCION that one can buy from Anapaya, for example, that provides those features here that rely on SCION. We are also working on making the systems that are not depending on SCION, so the last two, the programmable data planes one, more mature and more deployable. And once we have that, we could have the military-grade wide area networks on shared infrastructure that Vincent was mentioning before, with high security, resilience, scalability, and performance. With that, I'm coming to the end of the presentation. As a reminder, this is just one thing that we are doing with SCION. We have many other activities. If you are interested in learning more about them, just approach us afterwards. And now, thank you for your attention, and we are happy to take questions.